In this lesson, we will learn how to convert numbers between binary, octal, decimal, and hexadecimal systems. We will study decimal to other systems to decimal, binary with octal and hexadecimal, and finally conversions that contain fractional parts. Before converting, remember the base. Binary is base 2, octal is base 8, decimal is base 10, and hexadecimal is base 16. The base decides the division or positional values we use. To convert a whole decimal number to another system, repeatedly divide by the target base. Record each remainder. Continue until the quotient is 0, then read the remainders from bottom to top. For decimal to binary, divide by 2. Using 122 as the example, the remainders read upward are 111, 1010. Therefore, 122 decimal equals 1111, 010 binary. Some of the examples for decimal to binary conversions are given here. You can pause the video and observe it carefully. For decimal to octal, divide by 8. For 122, the remainders are 2, 7 and 1. Reading upward gives 172. Therefore, 122 decimal equals 172 octal. For decimal to hexadecimal, divide by 16. Remember that remainders 10 to 15 use A to F. For 122, the remainder is 10, which is A, and the next remainder is 7. So the answer is 7A hexadecimal. Some of the examples for decimal to hexadecimal conversions are given here. You can pause the video and observe it carefully. To convert binary, octal, or hexadecimal to decimal, use positional values. Multiply each digit by the base raised to its position, then add all the products. For 1101 binary, use powers of 2. 1 times 8 plus 1 times 4 plus 0 times 2 plus 1 times 1 gives 13. So 1101 binary equals 13 decimal. For 172 octal, use powers of 8. 1 times 64 is 64, 7 times 8 is 56, and 2 times 1 is 2. The total is 122 decimal. For 7A hexadecimal, use powers of 16. A represents 10. 7 times 16 plus 10 gives 122 decimal. To convert binary to octal, group bits in threes from right to left. Add leading zeros when needed. In 1111010, the groups are 001, 111, and 010, giving octal digits 1, 7, and 2. So the answer is 172 octal. To convert octal to binary, replace every octal digit with 3 bits. In 172 octal, 1 becomes 001, 7 becomes 111, and 2 becomes 010. Joining them gives 001111 010 binary. To convert binary to hexadecimal, group bits in fours from right to left. Add leading zeros if required. The groups 1111, 010 become 7 and A. So the answer is 7A hexadecimal. To convert hexadecimal to binary, replace every hexadecimal symbol with 4 bits. For 7A, 7 becomes 0111 and A becomes 1010. Joining them gives 01111 010 binary. For the fractional part of a decimal number, multiply repeatedly by the target base. Write each integer part from top to bottom. For 0.25 decimal to binary, the integer parts are 0 and 1, giving 0.01 binary. To convert a non-decimal fraction to decimal, use positive powers on the left of the point and negative powers on the right. For 1001001.101 binary, the integer part is 37 and the fraction is 0.625, giving 37.625 decimal. For fractional binary to octal or hexadecimal, group the integer part from right to left and the fractional part from left to right. Use groups of 3 for octal and 4 for hexadecimal, adding zeros when needed. Let us recap. Decimal to another base uses repeated division for whole numbers and repeated multiplication for fractions. Other systems to decimal use positional values. Binary and octal use 3-bit groups, while binary and hexadecimal use 4-bit groups. Thank you for watching this video. For more computer science revision, visit www.tuitionharbour.com or email at hello@tuitionharbour.co.uk.